Welcome to The Explainer. Today, we're going to pop the hood on our power grid. You see, it's going through this huge behind-the-scenes evolution for the green energy transition. And to survive, it's literally being forced to grow a digital brain. So let's dive right in, because the answer is changing absolutely everything about how we keep the lights on. For 100 years, our grid was all about raw physical force. Now, it's becoming a system that's all about lightning-fast software and pure digital logic. So here's how we're going to break this all down. We'll start with the big picture, the old grid versus the new one. Then we're going to dig into the really critical new problems this change is creating. And of course, the brilliant digital solutions engineers are cooking up to solve them. All right, so to really get this, you first have to understand the two main characters in this story. The entire personality of our power system is being rewritten, and it all boils down to this one fundamental difference. This right here explains the core conflict perfectly. On the left, you've got the old grid. Think of it like a heavyweight champion, relying on these huge spinning metal generators for stability through sheer physical momentum. And on the right, that's the new grid. It's more like a nimble, lightning-fast fighter, using silent electronic inverters to hook up all that solar, wind, and battery power. Okay, so this is where it gets really interesting. This shift from physical muscle to a digital brain creates a brand new and kind of scary problem, one that threatens the grid's natural stability in a way we've never, ever seen before. You see, in the old grid, all those massive spinning generators gave us something called inertia, and it was basically a free built-in safety net. It's the grid's physical momentum. So if a giant power plant suddenly tripped offline, the immense weight of all the other generators still spinning would just absorb that shock and keep the whole system stable. And this chart? Wow. It shows you just how insane the difference is. Solar panels, wind turbines that connect through inverters, which have practically zero physical inertia. So as we add more and more renewables, the grid gets lighter and way more volatile. It's like trying to balance a feather on your finger instead of a bowling ball. So here's the kicker. Without that big physical buffer, any little disturbance can make the grid's frequency, its very heartbeat, wobble so fast that it trips safety systems all over the network. And that can lead to cascading blackouts. It's a huge risk. But the solution engineers came up with, it's honestly genius. They basically taught the new grid's digital brain how to act like the old grid's physical muscle. They call it synthetic inertia. Smart inverters are now programmed to watch the grid's frequency, and if they see a wobble, they inject a blast of power in milliseconds to stabilize it. It's a digital shock absorber built entirely out of code. Okay, so we've got a digital fix for stability. Awesome. But that's just one piece of the puzzle. The next massive challenge is safety. The way we spot dangerous problems, like a short circuit, has to be completely reinvented, because on the new grid, they're practically invisible. See, back on the old grid, a fault, like a tree falling on a power line, was a big, dramatic event. It was a lightning bolt. A traditional generator would just dump a massive surge of current into the line, like 5 to 10 times the normal amount. That huge spike was impossible for safety gear to miss. But an inverter? It's a totally different story. It's designed to protect its own delicate electronics, right? So during a fault, it only nudges its output up a tiny bit, just 1.1 to 1.5 times normal. So that dangerous fault goes from a massive, obvious explosion of energy to a tiny, almost invisible flicker. It's a whisper instead of a shout. So this forces engineers to get way, way smarter. Instead of just looking for a big surge of current, new protection systems use high-speed fiber optic communication to talk to each other and confirm that yes, there's a real problem. They use intelligent relays that can change their own settings on the fly depending on what the grid is doing. It's a total shift from brute force to this really intelligent surgical approach. All right, let's talk about control, because this is another huge one. Think about it. The old grid was like a simple orchestra conducted by a handful of giant power plants. The new grid? It's more like a chaotic symphony with a million tiny instruments. Every rooftop solar panel, every electric car, all trying to play at once. How on earth do you get them all to play in tune? And the answer, believe it or not, is software, a new kind of grid operating system called a DERMS. You can think of it as the digital conductor for that chaotic symphony. It's a software platform that can see, talk to, and orchestrate all of those millions of scattered resources. And this quote right here just nails it. A DEMS lets you bundle all those thousands of little solar rooftops and home batteries together into what's called a virtual power plant, or a VPP.
All of a sudden, to the person in the control room, that chaos of a million different voices starts to sound like one single controllable power plant.
And the scale here is just mind-blowing. Get this. One utility actually pulled together over 10,000 homes with solar and batteries to create a 50-megawatt virtual power plant. That is powerful enough to do the same job as a traditional natural gas peaker plant, and it's all done with software. Incredible. So when you put all of this together, what you're really seeing is this fundamental shift in philosophy. Grid management is moving away from a system that relied on physical brawn to one that absolutely depends on a really sophisticated digital brain. And a huge piece of this new brain is the actual hardware itself. We're talking about a massive leap in semiconductor technology. It's like upgrading the grid's reflexes from an old-school rotary phone to the latest smartphone. This new tech is faster, it's way more flexible, and it can do all these complex things that the old tech just couldn't dream of. And all this new tech forces a completely new way of thinking for the folks running the grid. It's called the black box mindset. They can't possibly know the complex guts of every single device out there. Instead, they have to manage them like software modules, focusing only on what they do, their performance, their reliability, and how they behave on the network. So as we complete this incredible shift, here's the big question we're left with. We're solving these old physical problems with absolutely brilliant digital solutions. But as our grid's brain gets more and more complex and more essential to everything, you have to ask yourself, are we creating entirely new digital risks, new blind spots in the code that we can't even see yet?